In this projectile motion video, I want to take a look at how far has the ball, or what is the velocity of the ball 1 second into its path. Well, we know that if we go back to here, that the horizontal component is always constant. So if it projects at 8 meters per second horizontally off of the ledge, then it will continue to go at 8 meters per second the entire path. So any point on the parabolic path that it follows, it will be at 8 meters per second. The difference being, if we go here, the vertical is accelerated. So now the question is, what is the vertical velocity of this object as it falls? Well, 1 second later, what is the vertical velocity? And let me see if I can straighten this up a little bit. There we go, that makes me feel better. Okay, so we have it at 1 second. What is its velocity? And so we're going to use the parallelogram method. I know that this is 8 meters per second. What is my vertical component? Well, in our formula that we had, we're going to use this formula here. Final velocity is equal to initial velocity plus gravity times time. We know our initial velocity is 0. So my final velocity, or my velocity at this point, is going to be negative 9.8 times 1 squared. So the velocity after 1 second is a negative 9.8 meters per second. So we know we have our down vector, so that's going to give us a velocity of 9.8 meters per second. So as a result of that, I'm going to make my parallelogram. I'm going to use that method. And so here is my resultant velocity for this point. So what I need to do is my Pythagorean theorem. I can say 8 squared plus 9.8 squared is equal to c squared. Do that math. I know that my c, after I square root my answer, my c is 12.65 meters per second. So right here, this is 12.65 meters per second. And it is still negative, but the vectors are telling that because it is going down. So my velocity is a negative 12.65 meters per second. Now I need to find the angle. At what angle is this going down? And so I've got all three sides to my triangle, so I can pick any one that I want. So I'm going to say that the sine of my angle A is equal to 8 divided by 12.65. So angle A is going to be 39.23 degrees, and it's this angle here, so we're going to say that is east of north. But what we can also say in projectile motion, that this is 39.23 to the vertical. So either way, we can say it both ways. So this is how we find out how far this has fallen, or what its velocity is after 1 second. Let's do one more example. Pretty much the same thing. So let's say I've got an object, and let's give it a horizontal velocity of 10 meters per second. What is the velocity? Let's take this down. Let's go this time. Let's go 2 seconds. What is the velocity 2 seconds later? Well, we once again know that my horizontal velocity never changes. That is constant, so that's going to be 10 meters per second. Accelerated after 2 seconds So if we have this at 2 seconds, what is the velocity, the vertical velocity? And what is my vertical velocity after 2 seconds? Well, my y velocity is equal to a negative 9.8 times 2. Well, that's 19.6 meters per second. So this vector is 19.6 meters per second. So using our parallelogram method, once again, bring that down, bring that over. We're finding the resultant velocity here. Can't draw a straight line. And for that, we're going to do, let me pull this up a little bit. So for that, we are going to take my vertical and my horizontal. We'll say 10 squared plus 19.6 squared is equal to c squared. So the square root of my answer is going to be 22 meters per second at what angle? So we're going to find this angle once again. So that's going to be, change colors so we can contrast. That's going to be the sine of A is equal to 10 divided by 22, and that is going to be equal to 27.03 degrees. So my answer is 22 meters per second at 27.03 degrees to the vertical. You can practice this. Go 1 second, 2 second, and what you will notice is when you do that, this angle keeps changing as you go down. This is going to stay constant. My horizontal component will stay constant, and of course my accelerated component is going to change every second. So you can calculate every second what your velocity will be at the end.